same. Get two graphs ready. Did I go too quick on the last one? You're okay? So in blue, I'm going to graph the bottom. And then in green, graph the reciprocal. Uh-oh, the blue one is not in vertex form. So option one, change it to vertex form, right? That could be an option. Or option two, look at it, is it another form that we know? Do you remember what we called this form? I'll give you a hint. It's the form when it is factored. It is called the factored form. You guys are amazing. Okay. So we have the factored form. Why is the factored form nice? What does the factored form tell us right away? The x-intercepts. We know there's going to be one at 1, 0, and we know that there's going to be one at -1, 0. That's super helpful. And if you have both x-intercepts, could you use those to find the vertex? Yes. Do you know your vertex has to be right in between them? So your vertex is going to be when x is 0. And you could take 0 and plug it in right now. And you would get negative times a -1 times a +1, which is positive. 0, 1. You could also see that the vertex might have been 0, 1, because if you multiplied this out, you see that you would get a -1x squared with other stuff afterwards. And that -1x squared means you go over 1 down 1. So you're like, oh, if I went over 1 down 1, but I'm here, I could go up 1 over 1 to find my vertex. And the other thing you might do is you might go, oh, I just noticed this is a difference of squares. So that's easy to multiply. It'd be -x squared minus 1. And if I distributed my negative, I'd get -x squared plus 1. And now it is in vertex form. Usually factored form doesn't like immediately go to vertex form, but it does if they're differences of squares. And of course then we could go over 1 down 3 to find another point. So I have 2, -3 over 1 down 3. -2, -3. Again, you're going to have to, like, how much have we done with parabolas this year? A lot. You're going to have to do a lot of graphing and know how to work with them on your exam. So this is kind of nice that it reviews it. Now when we go to our reciprocal graph, you might even want to start right away with y equals 0. Your horizontal asymptote for sure will be there. We do have two x-intercepts. So at x equals -1 and x equals 1, you're going to have your vertical asymptotes. Now we take our points. You have -2, -3. Well, that's going to go to -2, 1 over -3. We have 0, 1. That's going to go to 0, 1. And 2, -3 to 2, 1 over -3. And each of these graphs is sort of in a different section because your non-permissible values, your vertical asymptotes, sort of break your graph up into different sections. But even having just one point in a section is enough to be able to draw towards the asymptotes. Now in the middle section, sometimes students are like confused. They're like, well, okay, I only have 1 point. Should I go up towards the asymptote or down towards the asymptote? Well, a 1 over graph never has any x-intercepts. And the reason for that is the only time a fraction is equal to 0 is if your numerator is equal to 0. And your numerator is a 1. Last time I checked, 1 is not equal to 0. So that would mean there can't be x-intercept. It has to go up towards these asymptotes. And finally, in this section, draw it towards the asymptotes. And we have Batman. Alright, so for this one, you can also circle 7, 8, and 11, C.